Hello, my name is Varun, and I'll be presenting our work titled PowerCut and Obfuscator, an exploration of the design space for privacy-preserving interventions for voice assistants. This is joint work with Suman, Bilge, Kassem, all from the University of Wisconsin. Voice assistants are pervasive in American households. As of 2020, nearly 20 million households had one. Voice assistants are commonly used for many household tasks, including home automation, interaction with various third-party applications, and often as an information bank. Voice assistants also have other uses, ranging from playing music to creating lists. Voice assistants, however, introduce several privacy issues. There's widespread coverage of how Amazon's Alexa accidentally records conversations. Recently, Google and its Home Assistant were sued for privacy violations, and the same for Amazon's Alexa. These are broadly categorized as passive privacy threats due to the accidental nature of the recording. Recent academic works have demonstrated how an adversarial entity can embed vocal commands in the inaudible spectrum. These are broadly known as active threats. In our work, we wish to understand how a privacy-preserving intervention against such threats ought to be designed. There are several solutions to preserve user privacy. One could intercept the network traffic from the voice assistant and prevent leakage of sensitive information. One could also modify the hardware to ensure that the behavior is privacy-preserving. A simple solution involves changing the wake word to avoid accidental activations, or the Hail Mary solution is simply discarding the smart speaker. The first approach, however, is unintuitive for the common user. Additionally, it is still susceptible to both forms of threats. Finally, dealing with encrypted traffic is tricky. The second approach largely has the same issues as the first. Changing the wake word is simple to do. However, it does not protect the user or the smart speaker from active threats. Finally, discarding the smart speaker is a non-utilitarian private solution. To better understand how an intervention ought to be, observe that the smart speaker is capable of processing speech from any direction. Based on interactions with end users, we understand that the privacy metaphor that they relate to is that of a virtual veil. This can be thought of as a mechanism that shrouds the smart speaker, rendering it ineffective. This can be realized in two simple ways. First, a mechanism can be developed to disrupt the power supply to the smart speaker, rendering it ineffective. Alternatively, one can design a mechanism to ensure that the user's speech is drowned out by another signal. This renders the smart speaker useless as well. Concretely, we utilize disengaging power using a remote control outlet and jam out the user's command using a remote control device that generates human inaudible ultrasound. The ultrasound, however, is audible to microphones of smart speakers. These are prototypes whose primary aim is to elicit feedback about different design dimensions. They have various pros and cons, but the commonality is that when engaged, they provably protect the end user's privacy. We compare these prototypes with an inbuilt baseline, the mute button. To achieve our goal of gaining insight about the design dimensions of privacy-preserving interventions, we follow a tech probe approach. We utilize the university mailing list to recruit participants from around the campus. In total, we recruit 30 participants from 24 families. Each of these participants were paid $40 to participate in our IRB-approved study. Our study spanned 2 years. We conducted an initial set of interviews in 2018 and another set in 2019 when the adoption of smart speakers increased along with the privacy concerns about them. The data was transcribed and coded by 2 coders independently. The outcome of the coding process is described in our paper, along with other details about the experimental setup. I strongly encourage you to read about it. Through our analysis, we discovered several important themes that are important to end users. A privacy-preserving intervention should have the following properties. It should be aesthetically appealing and integrate with existing decor. It should also provide a relatable privacy metaphor, like the virtual veil we propose. Its state of operation must be clear through an LED indicator. It should be cheap and should be cheaper than a smart speaker. In particular, this is important when the user has multiple smart speakers at home. It should be easy to deploy and easy to fix when things don't work the way they should. Privacy protection should be its secondary functionality. Notice that the intervention here is part of a desk light. It would also help if the intervention came from an organization which is different than the smart speaker manufacturer. Finally, people prefer hands-free interaction with the intervention and expect fine-grained per-user privacy control. Achieving some of these properties is the subject of future work. Thank you for listening. I'm looking forward to any questions you may have.